Okay, so what we're looking at now is how to solve questions with a solenoid. So we're going back a couple sheets to the previous ones that we did, where we looked at straight conductors, and now we're going to look at coiled or solenoid type conductors. Again, in each case, it says draw the positive and negative terminals of the battery, the direction of the conventional current flow, and the magnetic field north and south poles. Sketch it in. So let's take a look at the first one. So again, I would urge you to try these on your own first and then watch this video tutorial. So what we have is the positive end of the positive end of the terminal and the negative end of the terminal. And then we draw the current like this, and it's going up and up, 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 and it comes back this way. So that's the direction of the conventional current flow. Now, what we talked about before, again, you wouldn't draw this in, but it says, what side's the north of this magnet, which side's the south. And so, oh yeah, I've got all that done. And so the right-hand rule would tell us that this side here is north and this side here is south. Now, how did I do that? Again, what I'll do is draw the hand. And again, you don't have to draw this part of it. I'm just trying to show you how your hand would grip it. So again, your fingers want to point in the direction of, so you wrap your hand, your knuckles around it. And once you do that, your thumb points. This is your right hand, of course. And so your right hand points in the direction, your thumb points in the direction of the north, and my fingers curled around the conductor. Okay, so that is what you do for that. And what we're going to look at now is the next one. So in this next one, we've got, this is the negative terminal, positive terminal. The current is therefore flowing positive, negative. Conventionally, it goes around the back, down the front, around the back, down the front, down the front, down the front, down the front, like so. Now your hand reaches from behind, and you curl your hand around, and your thumb points in this direction here. So that is going to be the north, and that will be the south. And so what you can see here is that if I draw this in, and again, this part you wouldn't do, but my fingers curled around, I can draw it better this way for sure. Like that. Okay, and then your hands around the back, like this, and your thumb is pointing on the other side of the conductor, or sorry, on the side of the electromagnet, it's pointing in that direction. Okay, so that is our north and our south. All right, in the next one here, it's going to ask us to draw what it looks like in a situation where there is a this situation where that's north. So again, if you look at the way it's wrapped, it's actually wrapped the same as the one above, and so you can easily see that if you point your thumb in the direction of north and you wrap your hand around this conductor, your fingers are pointing in this direction here, like that, which means that the current is going this way. And so if we draw it, we know that this side has to be positive, like that. And that is basically the same situation as above. Okay. Next one. Here we have north and south. Now you may think that, if you take your thumb and you point it north, and then you have to wrap your fingers around from the back, the current is going this way because your fingers are wrapping around from the back. And again, if you want to see what that looks like, I'll draw it in a second. But now the current's going this way. And so that means that this side's positive, like this, and that side's negative. Okay, so that's how that works. And again, if you want to see that hand wrapping, it's the same as before, where your hand wraps around. These are my fingers. Very badly drawn because it's my right hand. That's what it would look like, and my hand would be on the other side. Okay, but because it's wrapped the opposite direction, now the positive and negative terminals switch. All right, what does it say here? It says the permeable core in these electromagnets is made of a, and the answer is ferromagnetic material. Okay, like that. The three ferromagnetic materials, so you just grab these words here, stick them here. Materials are iron, nickel, and cobalt, like so. Why is a permeable core used inside of a wire? It strengthens the magnetic field. And that's because of the domain theory of magnetism, right? So if you have a permeable core sitting in there and all those domains, if you have a coil of wire wrapped around it, like so, and it produces a magnetic field, well, then you can point all of the domains are all going to point in the same direction. And if they all point in the same direction, especially if it's a really strong ferromagnetic material, if they all point in the same direction, then what ends up happening is you get a very strong magnetic field. And that's why that works. Okay, we're going to go to the next one, which is the one last bit of practice. And that is here. And so what we're looking at here, same thing. I just set it up differently. This is positive and negative. Like instead of drawing this terminal like that, then what we're going to do is I just showed it as positive and negative. Again, I'll change the color. Let's try this, make it a little bit thicker like that. And you can see it flows positive to negative. So you always draw the direction of the current like this. Wrap your hands around. That's north, that's south. So your fingers point in the direction of the field. Your thumb points north to south. Here, positive to negative. So it's going positive to negative like so. Wrap your hand around. Thumb points that direction, north and south. Positive to negative. Wrap your hands around. Thumb points to north and south. Okay, so that's it. And hopefully you got those correct when you were doing yours.